GATE 2021 Physical Metallurgy. Which one of the following elements alloyed with iron is a ferrite stabilizer? So, uh, the ferrite stabilizers are chromium, molybdenum, tungsten, vanadium, beryllium, silicon, aluminum. And austenite stabilizers are manganese, nickel, nitrogen, cobalt, copper. And in some cases, it is given as zinc, but this is avoidable. So, the ferrite stabilizer is the nickel is an austenite stabilizer, manganese is an austenite stabilizer, carbon carbon is also an austenite stabilizer, so silicon is the answer. Which one of the following is decreasing sequence of quenching power? Quenching power. If you'll see the quenching power, generally for brine, it will be greater than water. So any case, brine is greater than water. Water has more quenching power than oil. So brine, water, oil, this is a sequence which is greater than air. But if you'll see the agitated conditions, agitated brine has more than agitated water. Then comes brine and then comes water. Then agitated oil, then oil, air, etc. Consider the homogeneous nucleation of a spherical solid in liquid. For a given undercooling, if surface energy of nucleus increases by 20%, then the corresponding increase in the critical radius of the nucleus is. So, if you will consider critical radius for a homogeneous nucleation, activation energy for the nucleation is delta GV into 4 pi by 3 R cube plus surface energy into 4 pi R square. So to calculate critical radius, you need to uh, find the maximum radius at which the activation free energy is zero. So you differentiate it and make it zero. So you get critical radius as minus 2 gamma by delta G. So here it is given as the critical radius, uh, the surface energy is increases by 20%, then the critical radius will increase by as critical radius is directly proportional to surface energy. So uh, R, R final minus R initial divided by gamma final by gamma initial. So if this is 1.2 and this is 1, then RF is 1.2 times of RF. So RF minus RI by RI is equal to 1.2 minus 1 by 1, which is 20% or 0.2. As it is given in percentage, 20%. If saturation magnetization of iron at room temperature is 1700 kilo ampere per meter, then the magnetic moment per iron atom in the crystal is dash into 10 power minus 23, round up to one decimal. The lattice parameter of the iron at room temperature is 0.287 nanometers. So we know saturation magnetization M is equal to N into N by V, where N is the net magnetic moment, N is the number of atoms per unit cell, and V is the volume of the unit cell. So now it is given as 1700 into 10 power 3 and N into 2 by, as it is BCC room temperature, the iron is BCC structure, right? So BCC has totally on body center and corner. So it has totally 1 plus 8 into 1 by 8, 2 atoms totally by 0.287 into 10 power minus 9 whole cube. And this is equal to N equal to 2 into 10 power minus 23 ampere meter square. So answer is 2. An X-ray diffraction pattern of FCC crystal, the first reflection occurs at a Bragg's angle of 30 degrees. The Bragg's angle for the second reflection will be, okay. In an FCC crystal, you know, the angles are in the ratio of 3 is to 4 is to 8. This is proportional to sine square theta 1 is to sine square theta 2 is to sine square theta 3. So, sine square theta 1 by sine square theta 2 is equal to 3 by 4. This is the ratio between first angle and second angle. First angle is 30 degrees. So, sine 30 is 1 by 2, 0.5. So, here you get the first angle, sine square 30 is 0.5. So, 0.5 square by sine square theta 2 is equal to 3 by 4, which is equal to sine square theta is equal to 1 by 3. So, sine theta is equal to 1 by root 3. So, theta is 35.26 degrees. The 0.68% carbon steel sample is slowly cooled from 900 degrees centigrade to room temperature. The fraction of the pro-eutectide ferrite in the microstructure is given. Eutectide composition is 0.88 percentage carbon. Maximum solubility of carbon in alpha iron is 0.025. So it's given as 0.025 and eutectide composition is 0.8. The pro-eutectide ferrite composition is alpha. So here 0.6 is given. So you need to find this part, pro-eutectide ferrite. Sorry, this part. Pro-eutectide ferrite is this one and eutectide part is this one. So F alpha is equal to 0.8 minus 0.65, 0.8 minus 0.025, which is equal to 0.258. So it is 0.26. If the degree of polymerization of polythene is 30,000, the average molecular weight is, here atomic weight of carbon is 12 and hydrogen is 1. So for polyethylene, the molecular formula is C2H4, which is equal to 2 into 12 plus 4 into 1. So this is 28. The degree of polymerization is nothing but average molecular weight by molecular weight of monomer. So we need to find the average molecular weight. So average molecular weight is equal to DOP 30,000 into 28, which is equal to 840000. So answer is 840000. The hypothetical binary alloy eutectic phase AB is shown below. An alloy with 5 weight percentage B solidifies with no convection. Assuming steady state, the critical temperature gradient required to maintain planar solidification front is. So here it is given as diffusivity is 10 power minus 9. The delta T by delta X is equal to delta T by D by velocity. Okay. So what is asked is the delta T is 775 minus 700 by diffusivity is 10 power minus 9 by velocity is given as 4 into 10 power minus 6 micro meter per second. So it is given as 30000 Kelvin per meter. So it has asked in Kelvin per mm. So you can write as 300 Kelvin per mm. So answer is 300. A thick steel plate containing 0.1 weight percentage carbon is carburized at 950 degrees centigrade. The plate surface carbon concentration is maintained at 1.1 weight percentage carbon. After 9 hours, the depth below the surface at which the carbon uh, concentration is 0.6, carbon will be dash. So diffusivity of carbon is given in austenite at 950 degrees centigrade is 1.6 into 10 power minus 9 and ERF Z values are given. So we know Cx minus C naught by Cs minus C naught is equal to 1 minus ERF x by 2 root dt, which is equal to 0.6. Cx is given as 0.6 concentration initially, and initial concentration, the concentration at x is given as, at the depth is given as 0.6. The concentration, uh, the surface concentration is maintained as 1.1 and initial concentration is 0.1. So 1.1 minus 0.1 is equal to 1 minus ERF by x by 2 root dt. So we get 0.5 by 1. So it is 0.5 and 1. So ERF x by 2 root dt is equal to 0.1. When ERF value is 0.5, you need to do extrapolation here. So it is 0.5. Then what is the value of Z? So Z minus 0.45 by 0.5 minus 0.4755 is equal to 0.5 minus 0.45 by 0.5205 minus 0.4755. Z is equal to 0.477. So x by 2 root dt is equal to 0.477. And putting the values, you get x is equal to, here diffusivity is given as 1.6 into 10 power minus 11. And time is given as 9 hours. So 9 into 3600. So x is equal to 0.7 mm. So it is asked in mm, 0.7. The radius of an interstitial atom, it just fits the inside the octahedral void of a BCC iron. In a BCC iron, octahedral void radius is equal to 0.155 of radius of the iron atom which is present. So here it is 0.155 into 0.124, which is equal to 0.01922. So it is 0.019 nanometers.